Le prochain projet aussi, j'étais très heureuse quand on me l'a soumis parce que je pense que c'est tout ce que Visualisation Montréal est à propos. C'est un très beau projet, c'est interactif, c'est percutant, puis c'est à propos de Montréal. Donc, moi, je suis extrêmement heureuse d'accueillir Tyler Sloan pour nous présenter son projet. Puis, essayer de changer de slide en même temps. Thank you, Tyler.
Merci. Bonsoir tout le monde. Moi, je m'appelle Tyler Sloan. Je vais continuer en anglais pour les raisons qui sont claires, parce que ça va être mieux pour tout le monde. Mais s'il y a quelqu'un qui a une question pour demander en français, ça ne m'inquiète pas du tout. C'est juste, ça va rouler mieux. Okay, so my name is Tyler Sloan. I was professionally trained as a scientist, studied developmental neurobiology. I decided to change career paths a little bit, go down a more artistic route. I started Colorimetric Studio. I run this from my house, and I work a lot with scientific analyses, kind of data science as a freelancer. But I'm also moving a lot more into this intersection between data visualization and motion design. And so that's what I spend most of my time doing, and that's the project that I'm going to talk to you guys about today. So I brought a laser pointer, but I really enjoy the height of this screen. I might not even need it. I will point with my hands. So a lot of what I've been doing has been really encouraged by some of this big data geospatial visualization that I really enjoy. So this is an example from Nathan Yao of where people run in big cities. And so the way these kinds of visuals work is that smartphone data or Fitbit data is being collected by people as they're going jogging. And so there's this sort of bottom-up grassroots map being generated, so you find out where it is that people are actually spending their time while jogging. There's some very obvious things that you can pull out of this, that people generally tend to run on streets and on paths, but less obvious things that people really like running around the waterfront. And so I wanted to make one of these of Montreal. We have a wealth of information, thanks to the Montreal Open Data Portal, who I do not work for, I do not represent them, but I go to them for a very huge amount of my projects. So it's really something we're lucky to have. So what I'm talking about here is GPS data from this Montreal Trajet public mobility study. This is data from 2016. And so the way this worked was it was a smartphone application that people could download. And then when they would go to work or they would go home, they would get a little notification that would say, hey, have you stopped moving? You're home now? Okay, how did you get home? Did you take your car? Did you take a metro? Did you take your bike? What were you doing? Were you going shopping? Were you dropping off your kids at daycare? And so they collected all of this information, including timestamps, and so you could go in and access, in this big data set, each of the individual trajectories. I'm just going to zoom in on it a little bit more into this more downtown area. And you can see some of the constraints that I was dealing with while wanting to present both the geolocation of all of these points, but also choosing colors that were far enough apart to be able to distinguish them, while also maintaining the ability to see individual trajectories as well. Now this was a lot of fun, but it was really a precursor to something else that I wanted to do, which I love to see when this stuff comes alive. I like to see it playing out in real time or in pseudo real time, so you can really see the bustle of rush hour. And so that was the main point of this project, which you see here. I'm going to just do this, smooth maneuver to switch between tabs. And this is a 1 minute long video that's a highlight of this. And so I've collapsed this all down to the period of 1 day, separated by time, so you can see all the trajectories that occurred at that time of day. I really enjoy seeing the increase as rush hour starts and how bustling it is. And that was the energy that I was trying to portray. I do encourage you to go and check out the original version, because I only spent 1 minute of the talk showing this here, but the original one is between 3 and 4 minutes. I separated out each of the different modes of transit, and I also used this really cool resource that's the Montreal Street Map. So this is people went around different areas of Montreal recording all the sounds, creating a city soundscape. So I took a bunch of those and I mixed them together to create a backdrop and a soundscape that was appropriate for this. And so while I was working on this project, I didn't want to necessarily go down the route of the quantitative visualization of, say, making a two-dimensional heat map, using a lot of the color maps that we've already seen people discussing a fair bit today. I wanted to keep these different categories of data, but I also wanted to maintain the ability to see individual trajectories. And I'm not going to go into this in too much detail because it's something that's been covered at length already tonight, and far better than I would have done so. How would I do full screen? Sorry. And so I'm using a basic triadic of color distribution. I do the most scientific thing possible. I start with my favorite color, and then I find a few of the ones that are kind of as distantly related to that as possible to create the best contrast. Now, starting with these three colors that are fairly far apart, I've learned a lot tonight. So far, I know that this is really not necessarily the best way to start doing this. I've obtained a lot of tools that I would move forward with my practice as of tonight, but this is how I've done this, and it is a tool that I have found very useful. So I've left the URL there for someone who might be interested. So one of the things that's really works well in this type of color palette is that in these intermediary zones, you really do get to distinguish well between the two because the colors are so far apart. What I think works less well with using a solid color scheme is in the centers of your zones here. There it's hard to resolve individual points super well, and it means that you can't really get a good estimate of how much is going on in the center here. And since for all of my work I really want to be able to distinguish all the individual trajectories as they're playing out, sometimes really quickly and sometimes with a lot going on at the same time, so I wanted to try to find a solution to these constraints. It turns out there's also already a solution that's been solved, that's been found for this in a slightly different way. And so this is a very normal kind of scatter representation, categorized data. I'm going to break it down because I think there's some hidden things inside of it that we can use and apply to color to improve our process. So we have, most obviously, our independent variable is being encoded by the position along the y-axis. Position along the x-axis is encoding the different groups, but also the position along the x-axis is working to separate these individual points from within the category, from each other. And this is something that is done by default in a lot of plotting software. It wasn't done by default when I had started doing this in spreadsheets. And as you can see the middle version, when that's not done, you can see that it is drastically missing. You don't get to see how many points there are, and what you get is this overall, just this line, you don't really know what's going on. But then if you add variation in there and you add spacing between these points, to the opposite extreme, you see what you see on the far right there, where the category ceases to exist. It all blends together. And so I believe, and I will argue, that this same process, this same mentality can be applied towards color with those same warnings and those same boundaries. And so that's what I'm going to show and talk about for the rest of my talk. The image here on the far left is what you've seen already. This is where there's no variation in the color. Now I'll progressively add variation in the color. In the middle it's at 30%, and at the far right it's at 80%. So when you start adding a small amount of variation to your color palette, despite it being categorical data, it starts to give you the ability to more finely resolve the individual points. I think there's something that's a bit more natural about this kind of look. I've been thinking about why that would be, and think of the example of looking at a tree. If you're looking at a tree outside, it's covered in maybe tens of thousands of different leaves. They're all green leaves, but each of the greens look a little bit different because of the way that each individual leaf is oriented in a different way. It's reflecting light a different way. It might have more shading or less. So you don't see a uniform variety of green leaves. You see this kind of Gaussian distribution of green leaves. And it actually improves our vision and able to detect the differences inside of it. But like the example I showed you already, if you take it to another extreme, you go too far down the adding variance route, you start to lose the ability to distinguish categories. See here, you start to have these cyan points that are being drawn up from you start to see magenta points that are being drawn up from this originally cyan or green distribution. And you start to also see cyan points that are coming from this purple distribution. So you can't say with certainty from what categories any of these individual points came using just the colors. So like anything, it has to be used within reason. And I'm just going to take it away from the theoretical, and I'm going to show you kind of in situ what that would look like. And this is taking a very small portion of the map that includes probably the area that we're in right now, a bit of the downtown of Montreal. And we see when we use just these three very fixed colors, you're able to distinguish the categories very easily. However, there become certain points where you have so many lines that you can't necessarily tell how many there are, and you can't easily distinguish each of the different points. So that's where adding a small amount of color variance inside of this can help. I think when it's done tastefully and it's done within moderation, you don't lose the ability to distinguish between categories either. So here we can tell by looking at them that these are each closer to that magenta distribution than they are to any of the other ones. So when that variance is controlled, we don't lose the ability to see between categories. So I'm going to show another little video here. And I'm not going to run in its entirety because it kind of goes on for a little while. But I invite you to come and go and check it out. I have it on YouTube. I'll provide all the links and all that jazz. But this is a simulation showing increasing by increments of 10% of color variance. So here we have no color variation because these are all of the same color exactly. So while you can tell the difference between the different groups, telling between individuals is not quite as easy. And so as we start increasing, going up 10%, 20%, we start seeing what I would call a more natural color tone, so what we're more used to seeing in nature. And beyond that, I would call it a more aesthetically pleasing one as well. That's just my personal tastes, so I'm more likely to go on the opposite extreme because I just love color. But I think that it's something that it points to the way that we can all use this to varying extents depending on the context. So this is something on the slide I provided a little equation to do that in processing, which is where I do most of my work. I'm positive it works in Python. I'm sure it works in R, and I imagine it works in D3, but I'm not as familiar with those environments. It's really just adding random Gaussian distribution or noise to each of the individual color tones and applying those to each of the points. So I'm going to end that there. You can see it all the way up to, I think, 90% if you ever wanted to check that out. And then I'm going to end by going over a few of my take-home messages. Right here. And so using these randomly distributed color palettes can help you to distinguish between individuals within categories that are already being distinguished by color, This is something that's already being done with respect to spatial encoding in other visualization softwares. And like anything, this ought to be used with care, but the limits will really depend a lot on the application. For example, if I'm putting on my data artist hat, I will be able to apply this much more liberally than someone if they were to be using this for a scientific visualization that was going to go into an academic paper. But I think that it's something that everyone can play around with a little bit to find what they find comfortable. So thank you very much. I can take questions now or we can chat afterwards. Depends on what's best for time. Thank you. I also apologize for my usage of the microphone. I think it's been coming back and forth a fair bit. I'm really not used to this. So if anything I need to repeat, I am completely open to that possibility too.
When you showed the example with the line with the transit systems, right?
Mm-hmm.
Have you ever had a situation where somebody confused the variation of one color with, so you had 3 categories, but with one look, I thought it's a new category, but it's not 2 more, you know, blue and brown.
Mm-hmm.
And have you seen that kind of the confusion where people would see more categories than there are? How to prevent that?
I think that's almost certainly going to be happening when it's uncontrolled like this. One of the possibilities of doing that otherwise would be to, instead of using like a random normal distribution, would be just using a uniform distribution, so you're defining the bounds of the randomness. I don't particularly like the look of it. It looks like confetti streamers, where it's too out there. The range is too high, but it's something that could be used in order to confine those, to make sure that you're not creating completely new categories. And the other thing to do on that front would be to lower the variation that you're imparting, so that the average color is still going to be that one that's defined a priori in your color mapping, but then making sure that it's not going too far that you would start confusing too much. So it's something that for different applications I think would have to be explored as it comes. Mm-hmm. Are there other kind of strategies that you would use when the visualizations become a bit more complicated, such as using small multiples or adding jitter inside of there for best practices? I enjoy the use of jitter. In my case here, so in the first version that I showed you, I had actually added just a small nudge of offset in between the different trajectories. I didn't go into detail on that. Between the different modes of transit, I did that to create this appearance of bundling. And I think that is analogous to the jitter that you would maybe add in something that's a bit more dynamic. But so you can see here, the reason that there's systematically the gold points of the pedestrians are offset from the public transit is actually an artifact added in there in order to separate them out so you could see everything simultaneously. Now, for something like this, I had to use that very carefully to not just separate all the trajectories and make it look as though there are the grid of Montreal is twice as defined as it actually is. And so that was a constraint there. But as for the small multiples, in a more graphic visualization setting, if I was going to be doing this for a newspaper or for a kind of an online media application of some sort, I think a small multiples would be a good way of doing that, for sure. I've explored that a little bit, comparing between the different boroughs, but it's not something I can comment on too much more than that. But I think that would be a good direction to go. Thanks. If that's it, I'll say thanks again for the attention, and yeah, pass it on.
Thank you so much, Tyler.